So yeah, I'm Tereza, and today I'm going to be doing some demystification of parsers in Elm. Now, you might be asking, why? That's a reasonable question, because who cares about parsers? And until recently, literally the only person who I knew cared about parsers was actually Evan. And he'd be really weird about it too. He'd come over to me and be like, "Oh man, my parser is allocating even less now," and it's like, I don't know what these words mean. But little did I know, because I was like, this doesn't sound like something I just should get into. This sounds like something that would turn you into a crazy person. But meanwhile, so I'm working at Nordic, as some of you know, and at Nordic we have this one particular interview, which I conduct a lot, and it's basically so you have some data, and that data is in YAML, and then you parse the data, and you do some transformation on that data, and then you do a tiny visualization on it. But the YAML part is totally trivial in most languages, and doesn't matter to the interview, so it's a weird detail that shouldn't matter. However, so at the same time, we really encourage our candidates to use the language that they're most comfortable with. The problem is though that if you want to use Elm for this, it's a really bad choice because there isn't a YAML parser in Elm, so you just can't do it. Which is sad because obviously we get a lot of candidates who are really comfortable with Elm. So, so yeah, this might actually make me be somebody should write a YAML parser for Elm. And then weeks pass by and I'm like, I guess I'm making a YAML parser in Elm. So now I'm one of two people who care about parsers that I know. And but hopefully after this talk, there'll be a slightly broader interest. With those words, let's parse some YAML. Step one is knowing what a parser is. A parser is very simple in its most abstract form. It's really just anything that takes some input and turns it into a data structure, and that input is just in 99% of the cases just text. Some of the more common uses of parsing is, as Evan mentioned, programming languages, which is really funny because I always think of programming languages as something different, but it's really just text and then you read it and it's kind of weird. And then you can also parse natural languages. Obviously that's harder. And other familiar uses are you parse JSON and XML and YAML like we're going to be talking about today, and CSV and lots of other stuff. And the cool thing is that once you parse it and turn it into a data structure, you can do a lot more cool stuff with it. You can analyze it in different ways, you can visualize it, you can translate it. So it's really the step one of getting the data out of the file, and then you can get the information out afterwards. And so yeah, parsers are pretty simple, depending on what you're parsing. So this is what YAML looks like. As you can tell, it's a lot. So we're just going to be focusing on one types of list, which is the YAML lists, one of the ways. And so this is the text snippet that we're going to be parsing, and we want to turn it into the data structure of a list string. So how do we start doing that? Well, we can start by installing the library, which is called elm/parser, which is made by Evan, and it's great. I usually take a look at the API first, and that looks like this. And I was really pleasantly surprised because I thought parsers were going to be something difficult and hard, but I was like, this is just a JSON decoder, no trouble at all. Yeah, we'll see about that. So it has all the elements that I'm familiar with, there's an int and a float and one off, and then you just run the parser with the input and it gives back the result. Easy peasy. And I was further encouraged when I saw my first example, which was a little bit like this. So we have a tuple. This is our string. And we want to turn it into a data structure that is just this point where the first integer is the x and the second integer is the y. And the parser that we end up with looks a little bit like this. And so you might already be getting the point of this, but the only part that might be unfamiliar is these operators, and I like to think about them as in like the one with the dot, it just like eats the stuff and throws it away, and then the other one keeps the stuff. I just like things that rhyme, I'm sorry. It's not on purpose, it's compulsive. But what happens is that, so if we just go by it one by one, is that okay? It finds the parentheses and then it throws it away. Finds the spaces, throws it away. Finds the integer, keeps it. Finds the comma, throws it away. Space, throws it away. Integer, keeps it. Space, throws it away. Parentheses, and throws it away. So it's very important that, like, to get in this mindset of reading one character at a time. It's crucial for making parsers. But what happens now is that, okay, it has the 2 integers that it kept, and those are the arguments for the thing in the succeed, the function in the succeed one. If you ever work with the JSON pipeline library, it works kind of like that underneath. But let's see how this knowledge can help us make a list parser. So it starts out well. We can parse the dash. It's exciting. Actually, we want to parse the space afterwards as well, because that's required by YAML. But what's that? That's a T. A T for trouble. Because in our past example, as you just saw, we had an integer parser, and that made our life really easy. But if we look at the API now, where is string? And it actually took me a minute to realize why this is, because like everything is a string. Like your whole job making a parser is to define what a string is and what is trash and you want to throw away. So I was like, oh, this is harder now, but there is another part of the API which helps us out with that. So it looks like this. It's chomping. This library has great names in general, the whole thing. So the first one is chomp while, and you get this criteria, which is the check that it does on every character. And as long as that check returns true, then it keeps going to the next character, and once it is false, it stops. And with chomp if, it's very similar. You have the one criteria, except it only reads one, and the parser fails if the criteria returns false. Now, the observant listener will have noticed that these do not return a parser of string. It returns a parser of unit, which is silly, because I know how to make a unit. I don't need to parse it. But Evan thought of that, so he made another function called getChompString. And that does what the name suggests, is if you chomped some characters, then it gets you the string that you chomped. So this is all very abstract, so let's take a look at some examples first. So imagine that we have 123 lizards. This is heaven for some and hell for others, but if we just want to focus on the numbers here. And so we can do this by making a parser that looks like this. So we chomp while the character is a digit. And it goes 1, 2, 3. Those are all digits. When it comes to the space, it's like, oh, that's another digit. We're going to stop here. So what the result is of this is it will return 1, 2, 3, which is great. This is what we want. So what we're going to do now is we're going to create a little bit of helpers that we're going to use later. And we can start by making a string one that's a little more flexible. So we decide the criteria. We can use it around later. And it looks very much like the digit one, except we decide now. One thing that's worth noticing, though, is that chomp while always succeeds, meaning that if it doesn't find any of the characters that fit the criteria, it returns just an empty string, like it just doesn't chomp anything. And so a more appropriate name for this function is actually like 0 or more. So, and that implies that if we want to do a 1 or more, we want to use the chomp if function, because that will actually fail if it doesn't find one of the characters that we're looking for. Now, how can we use this for our list journey? So we still have this one, and this is how far we came last time. And we want to use 0 or more, because It can actually be an empty string, that's fine. And we want it to be not a new line, just the thing at the end there. And so we'll chomp up until the new line, and then it'll be like, then it stops. And then now we want to chomp the symbol, right? The new line. Or do we? It's very hard to make parsers this exciting, but I'm really trying. Because if you see on the next line, there isn't a new line in the end. There's the end of the file. So what do we do about these things that are sometimes, you know? Well, we can use the one-off, which is, if you use the JSON decoder, it's quite like that. So you take a list of parsers, which are your options that you want to check out, and it just takes it from the top. The first one parses, then great. If not, then tries the next. Or so we'll see. But if we try to use that in our case, it's going to probably go well. So we were here, and then we add a one-off and say, OK, if there's a new line, then we want to parse the next element in the list, and if not, then we're done. There is tricky stuff, though. So if you come from JSON decoders, and this is your metaphor to how to approach this library, then you're in trouble with this one, because it acts slightly different. For that purpose, we have a small example. So we have some strings, and they can be either dollars or something else, like it doesn't matter. And we want to turn it into a data structure that is dollars or not dollars, the two building blocks of the universe. And we can have a parser that looks a little bit like this. And so this is pretty straightforward. You ask, like, if there's a dollar sign, then we want to take the number afterwards and put it in our data structure, dollars. And if not, then we'll just take whatever it is, doesn't even matter, put it in the not dollars. Now, what about if there is somebody writes sucker? What will happen then? Well, it will come in and it'll be like, okay, we found the dollar symbol, but the int one is failing. And so if you come from the JSON thing, you'll just like, okay, well then it's failing, and then it'll just try the next one. That's not the case though, because we're committed to this path now. There's no going back once you ate the first character and accepted that this is the path that you're on. And so instead, we actually have to just continue down this path. And it's like, okay, is there an end? Okay, then we can come back up. And then, but if there's not, then we have to deal with that case itself as well. So the moral of the story is, once you go down a path, there is no escape. That's just how life is. You have to deal with it. And so this is actually not relevant for this, this thing, but it is an important lesson for dealing with parsers and others. But yeah, so there's some questions left from our previous progress. It's like, what is next? What is done? It's a good questions. I just made it up. Doesn't mean anything. What we want to do, though, is that when we find a new line, we want to somehow like go back up and parse the next entry. Like the next after the new line is the dash, so that's what we want to parse. And as you can imagine, you can actually just call it again and make a recursive parser, although that might end up in like some Stack Overflow things. So there's a special API for loops, which is what we're going to talk about now. And so the first function, as you can tell, is loop, and it takes an initial state, and then it takes a function which takes that intermediate state and returns a parser of step. And what is a step? That is a either loop or done. And if you turn loop, then we go back around, and when you're done, you're done. And so I don't like talking about types like this. It always confuses me. So let's just look at how it actually plays out. So this is what our parser would look like. So we start out with the loop on the empty list as our initial state. And then we do as before, we parse the dash and the turtles, and we find the new line. And if it's the new line, then we turn the loop, and then we end up in the finish function, and the entry is the turtles, and the next is the loop. We add it to our temporary list of strings and go back around, find the dash, parse the lizards, and then this time we find the end of the file instead, and we're done. And reverse the list because it's backwards. And that's it. Like, we can parse the list now. Like, that isn't even that crazy. So we learned about chomping, and we learned about parsing sometimes, and loops, and this is like 99% of like all the parsers that you need to do. So let's try our knowledge on something a teeny bit harder, which is YAML inline lists. And they look like this. They should be familiar. And so they would start out like this. So the only thing that's really different is that it's encased in these brackets. And so we want to start out like parsing that bracket and the spaces. Oops. And then we want to parse A, or do we? But then I already pressed the next one. Then it can be an empty list instead. So we want to actually ask ourselves, okay, is it the end of the list? And then we send back the empty list. And if not, we continue to the actual looping. And this one looks very much like the one before. You start out with empty string, empty list, and then you parse the A, and you end up like with the comma, and then you ask with the comma, go back with the loop, go back around to the next finish, and then trim it because there can be some extra spaces. You do it until you reach the C one, the C character, and then that's the end of the list, and that's good too. We made an inline list parser. That's great. Although there's no project in Elm that's good or finished before, well, it can be good, but it's not finished before it has good error messages. And the API for that is really simple. You just have a string, which is your error message, and you put it in wherever you need it. So in our past example, when we're doing, we want to eat one or more characters, we can make it into a more customized function where this is what it would look like now, and we just add it back in here. And then if we want to create an error for if we do not actually have a character that matches that, then we can put a one-off in, which is like the natural environment of the problem. And then if that one fails to chomp if, then we can set an error, say, okay, I was expecting at least one of valid element characters. And so if we want to apply that, we can use the entry in here that we just made, and we can add another one in the one off here. And that's it. And so parsers are actually really easy. Like, that's the point of this talk, is that like they're just really dumb. Like primarily, you just have to like pretend that you're explaining like a data format to someone who was born yesterday, and someone who was born yesterday and can only read one character and must absolutely know what to do next based on that character. So they're not scary at all, and I only have one recommendation before you start like parsing everything on the internet, as I of course know you will immediately when you come home, is that test-driven development is really excellent for parsers. It helped me so much just like creating a full suite of it, because the more complex your format gets, like the more edge cases there are, and like if you write many parsers and they're like inside each other, and you're like, oh, this is crazy. So like it's easy to just like run the test suite, and you feel a lot more comfortable with your parsers. Now there's one thing we haven't covered, which is the craziest part, which is the indentation. And so it's unappreciated Animals Appreciation Day, as you can tell with the goblin shark. But the way that I did this in the library was actually, I saw these like functions in the API, and I was like, I don't get it, so I didn't use those. I just used the get column. Like that was, I figured I can figure it out on myself. And so the way this works is that, okay, if you have this new list of ours, first of all, we have to change the data structure that we want to make it into, because now we can have, with not only a list of strings, the list can also have lists inside of itself, and it continues. So this is our new structure. And would end up looking like this. So the first thing is that we get, when we call this function the first time, we pass down 1, as in column 1 is the first one. And then for each step, I made this helper function, which just like asks, like, is the indentation we expect, like, what is it, like, so we can act relative to that indentation. So if it's smaller, then it means that we're going back into a parent array or list, and then we should be done. And if it's exactly, then we expect a new element. And if it's larger, that means like you messed something up and you have to give a problem, report a problem. And if it's ending, you're ending. And so in this case, when we read the text, it's like you start with the 0, and it is exactly, or sorry, start with 1, and it's exactly 1. We read the entry, we read 0 more, read the turtles, we find the, oh, we don't, because I forgot to write that up. We go back up, and then we expect another element and go down, and then we find the dash and the new line. And then we go to the next non-white space and get the column again. And now we're starting in the list again with a new indent. So the indent is now 3. And then we do it again all over. And so it's actually not that crazy. The function that I made, though, as a helper, you can look it up in the library because it's actually very simple. But with those words, we don't really have a lot of time more. So if you want to try out the library, you can find it on Tereza/YAML, or you can talk to me more about parsers if you want to. So yeah, thank you.